Welcome subscribers. Today we are going to just have a quick geometry on the circle here, and it will be a small problem. We have to prove in this image here that DC squared is equal to AD times DB. This is very used in the circle geometry, but we have to know how we found this formula, and if we are faced with problems involving this, it will be always good to know how to find it back when you forgot the formula. So if you took DC here and then DA or AD and DB, you have to say that DC squared is equal to AD times DB. So we are going to redraw here. We have two chords here, or segments, BC and AC. We added to the sketch to make things easier for us. So if we take segment BC here, you can see it here, and then segment AC, we get a couple of triangles, very interesting here. You can see we have triangle ADC and triangle CDB. We are going to compare them and see what we can find. Okay, so if we look at the angles of these triangles, we can have some relations. So we know that angle at C here, for the small triangle, we could say angle DCB or BCD is equal to half of the intercepted arc BC, correct? We can prove that in another video. Okay, make things short here. And the same way, if you look at DAC, angle DAC, it also intercepts the same arc here, and is also equal to half of BC. So we can infer that since angle BCD is equal to half of BC and angle DAC is equal to half of BC, arc BC, we can say that angle BCD is congruent to angle DAC. So it's the first relation we have. So for the small triangle we have DAC, and for the big one we have for the small one we have BCD, and for the big one we have DAC. Okay, and what we know also by reflective property, angle D is congruent to itself, or otherwise we could just expand that. What we want to bring home here is angle D taken from the big triangle. So from ADC is congruent to the angle D taken from the small triangle BDC. Okay, so we have now the angle similarity here. That means these two triangles are similar, and since these two angles have been compared, we can also, all the triangles are there, we can say that therefore triangle ADC is similar to triangle CDB. So okay, now we can have the corresponding sides. if we divide any corresponding sides, we get the same ratio. So that will lead us to the following relation. So if we took AD or DA, the longer side here for the big triangle, in triangle DAC, if we take AD, we divide it by its corresponding side on the small triangle DC, you can say is also equal to the side of the big triangle DC over its corresponding side on the small triangle, which will be DB. Okay. Seki, what shows that DC squared is equal to AD times DB. So that's all we wanted to show. Thank you for watching, and I hope it's not very long. We will solve problems using this formula. Bye bye.